Well, hello, and this video is going to help with 12.4, which is the definite integral or the start of our definite integral. And we're going to learn about Riemann sums in this one. So we're going to use this idea of Riemann sums. I know that your note packet probably doesn't have a lot of room for you to add this, but I'm going to add a page here, and I want to show you a little more than what they have for the notes part. So they just talk about Riemann sums without the visualization of it. I think it's a little bit harder. Oops, there we go. So what I want you to think about is we will have some kind of a graph. So I'm just going to draw a graph that maybe goes something like this. There's our graph, right? This is increasing graph. And let's say we want to know the area between number 1, 2, 3, 4, and number 4 here. We want to know the area under that curve and in that. So I'm going to highlight the area that we want. We want this area here. And we're going to estimate this with what we call Riemann sums. So what we can do is we can use little rectangles and fit them in there the best we can, and then find the area of our rectangles and add them up. That's what this whole idea is. Now, whether we start with the number 1 and go up and over on our rectangle versus maybe not starting with the number 1, kind of depends. So I'm gonna do this one in pinky purple. And if I started with the number 1 and I went straight up and hit my graph, hit the graph, right? Then went over to form my rectangle. Let me finish. At 2, I'm gonna go up, hit the graph, and go over. At 3, I'm gonna go up, hit the graph, and come over at 4 like that. Look at my 3 rectangles. I could easily find the area of those rectangles and add them up. Okay, so you can probably see that it is going to be missing this section, right? So this is going to be an underestimate. And what we call this is if we're starting with the number 1 and we go up on the left side of this first little piece here, we call that a left rectangle. So we're going to call this a left rectangle because we went up on the left area. So these are left rectangles, and we'd use those to estimate. We might also have right rectangles. So I am going to draw that same graph, but I don't want it to be messy. So I'm going to just draw it down here. I kind of went like this, and we have 1, 2, 3, 4. And this time for our rectangles, what we're going to do, I'll do this one in blue, is we're going to go up on the second number. So instead of 1, we're going to go up on the second number and hit that and go over and back down. Can you see why this would be called a right rectangle? Okay, and then I would continue that pattern. Second one, over, up the second one and over. And can you see that this is an overestimate because it has these little pieces here, right? So these are right rectangles. And when it's increasing, it is a overestimate. So I don't want to write that. I mean, you can, but right rectangles aren't always going to be an overestimate, because if it's a decreasing graph, then it's an underestimate. They switch. So for an increasing graph, left is under, right is over. Now, when I took Calc 1 back in, the 1500s, we would then average those two to get the best estimate, right? We would do left, right, and then average them, which we could do, but that's kind of a lot of work. Now, the other thing is you could have same graph, 1, 2, 3, 4. Mine's, although it's getting uglier, like 3 and 4 are pretty close together, but that's okay. We could also go up in the middle and then go over. Okay, so go up in the middle and over, in the middle and over, and this would be like a midpoint. Okay. Um, you have a couple problems in your homework that'll be like, is this a left or a right? And basically, you just have to look at the graph and decide. So we could, it doesn't always have to be left or right, right? It could be from the middle. So if I looked at a problem like this, look where the dot hits and goes over. Is it on the left of that area? See how it's left, left, left. This one's right, right, right. This one's middle, middle, middle. Even if they try to trick you, so I will attempt to trick you. I have something like this, and maybe I'll just do a couple more rectangles than I did on that first one, which is fine. So maybe this first one looks like this. Second one looks like this. One looks like this. We'll call that A, B, C, D, E, F, G. Okay, look at those for a second. Which ones are right rectangles? Oh, let's see. So left side, right side, over here, left, right. Just kidding. So this one is not a right. This one's a right, right? Because it's on the right side of this one. So just C is a right rectangle. What about a left? So left rectangle, I can see this one's on the left and this one's on the left. See? So there's two of them, A and D, and then midpoint, there's B. It usually only asks for left or right. That's kind of how we can start and how your homework will start. So if you are looking at a decreasing, then, it's still that same idea there. One other thing, it does talk a little bit about error bounds on one question. An error is basically for what is that error, on our drawings where I drew it a little bit better. What is that error here or here? So you might have one question just asking about that error a little bit. So let's look at a full problem. So our first problem says we have a function, so we have to have something to graph, and it gives us the function here. That's our function. It wants us to partition it from -1 to 9 into 5 subgroups, so 5 rectangles. And for each subgroup, it gives us all this information. So when you first start these, it's a little bit tricky. So I want to make sure we're going through each of these individually. So let's start with, what does the graph look like? So I'm going to bounce into Desmos just to show you what that graph looks like. And we are graphing 7 plus x squared. So there's what our graph looks like. That's going to be at 0, 7. And you can see here, this is 1, and it's like 1 is at about 9 or 8, excuse me, and so forth. So I'm just going to sketch that over here just a little. And we want to go from -1 here at -1 to 9. 1, 2, 3, 4, 5. Let's just break this up a little more. And we will change our 1 and -1 there a little bit. Otherwise, I won't have room. So here's -1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going from here See here. And then the graph is starting about here, and it kind of looks like this. No, we'll just go something like that. Okay, I'm going to go back to full screen. I want you to visualize the graph. Do you have to graph them? No, but I I think it will help you with the first one. So we're really looking for this area all in here that's going to go up a little bit weird. There we go. That's the area that we're wanting, the area under that curve. And what is it giving us? Well, this information looks a little bit tricky, but your x values that it's referring to, and it says case minus 1, and the other values here that they're referring to are a little bit tricky. What I want you to start with is that change in x. So our change in x, we know, is just the top number 9 on our x values, and we're going to subtract off the bottom value and divide that by the number of subintervals, so 5. So that becomes a plus of 10 divided by 5 is going to give me 2. So basically, you're going to have 2 x values for each rectangle. So we're starting at -1. We don't know where we're going to go up and hit, so I'm going to wait to draw it. I was going to sketch it a little bit, but basically we know it's going to go from -1 to 1. It covers 2 of them each time in order to make 5 rectangles on there. So change in x, subtract highest from lowest, and divide by the number of subintervals. That one's our first thing we want to do. And then it talks about this here, what are our subintervals? So we call the first one x sub 0. Seems weird, but you need 6 numbers to break something into 5 pieces because you need the end numbers, right? And you have an extra end. So we call it sub-0 where we start. Where we start is -1. Okay. If I'm counting by 2s, what would be the next number? That should be a 1. Sorry. Hold on. Oops. Okay, so the next one should be counting by 2s, because we're going up by 2s, is a number 1, right? Because we're going to go, because this is 0 right here. So you're going to go by 2s from -1 to 1. First group here. Then we're going to go from 1 to 3. So our next x number would be 3, and our next number would be 5, and then our next number would be 7, counting by 2s, and our last one would be the 9. So from -1 to 9, breaking it into 5 pieces, we're there, and that's what it's trying to tell you here. And then it's talking about C sub k. So basically, where in between those numbers are you going to go up and hit? Are you going to go on the left, on the right, or somewhere in the middle? Well, look what it says you're going to do. You're going to add the 2 numbers and divide by 2. So you are doing a midpoint, right? Because you're adding the 2 and dividing by 2. All this weird sub language, they're just trying to tell you, like, start with the first one, add it to the next one, divide it by 2, and follow that pattern. Okay, so I'm going to use their notation. C sub 1, my first C, is going to be where your k value is 1. So maybe I'll write that right above. K equals 1. That's where we're starting. And it is then saying, well, if k is 1, then you're starting at 0 and 1. So k sub x sub 0, x sub 1. Goodness gracious, it's so much notation. What is it really saying? It's trying to say start with the first number, add it to the next number, divide it by 2. So -1 plus 1 divided by 2 is going to give me 0. Okay, look over here. What number is in between these two? Right in the middle, it's 0. Maybe I'll do this. 0, right? And the next one that's in the middle is 2, and the next one in the middle is 4, and the next one is 6, and the next one is 8. So I bet those are the numbers we're trying to come up with over here because those are the middle. Add them and divide. So our next C number would be the next two. We did -1 and 1. The next ones would be 1 and 3 divided by 2. So 4 divided by 2 is 2, which we can see is our next one over here. Okay. And then our next number would be, the next two would be 3 plus 5, and divide that by 2, and I would get 5 plus this 8. 8 divided by 2 is 4. And then C sub 4 is going to be 5 plus 7 divided by 2, which is 6. And our last one will then be 7 plus 9 divided by 2, which is 8. Sweet. So why did we do that? Well, because now I can go up this middle one and go across and make my rectangles. I go up, I hit, so it's a midpoint. I go up, I hit, and it's a midpoint like this. Go up, hit. This is probably the ugliest drawing, but hopefully you get the idea. Those are my rectangles, and the middle number there, or the middle line here, is just representing the midpoint. These are the midpoints halfway through. All right, so once we have those numbers, what we're actually going to do is take each number, and we have to find, we haven't talked about this part, we can see the distance between the bottom is all going to be 2's. So if you just think about this first rectangle here, right? The bottom has got to be a 2 because it goes from -1 to 1, or it has a distance of 2. We set it up that way. It's your change in x. It's always 2. How in the world am I going to find this side right here that I just called y? That side refers to your function because it's where you go up and hit your function. So you can put the value that it wants, which is a 0 for the first one, because you're going down the middle at the 0, into the function. So I'm going to erase this little drawing, but basically I have to find that side part. So I'm going to do that by taking f of this 0, and then f of this 2, and f of this 4, f of this 6, and f of this 8. So those numbers are where I go up and hit the function. So if it was a left one, it would have been -1, 3, 7, and then the one above 9. Well, then it would have been 9. I guess I'm counting 6 of them instead of 5. Either way. So if it's a left, it would have just been the left numbers, right numbers, or middle. You have to find them. So then I'm going to go 7 plus, plus 0 squared. Excuse me. It's just 7. Okay, and then this one, 7 plus 2 squared. 7 plus 4 is 11. This one, 7 plus 4 squared, which is going to give me 23. 16 plus 7. And then 7 plus 6 squared. 36 plus 7 is 43. And 7 plus 8 squared is going to give me 71. So then I can form, we do a big S for Riemann sum of the rectangles. And we have 5 rectangles because we broke it into 5 pieces. And our first rectangle will then be our 2 and our 7. So 2 times 7 is the area of our first rectangle. So we're always using the 2 here, right? And the 7 here. Then we're going to add it to the next rectangle, which would be 2 times 11, right? Because 11 is what we got when we went up at the second spot. And then the next one would then be 2 times 23. And the next one would then be 2 times 43. And the next one is 2 times 71. And then we just put that into our calculator, and we should get 310. That is the area of the shaded region using rectangles. Think about it. the skinnier my rectangles, the more I have, the closer it'll be, the less error I have. Okay. This one's increasing. And I like the midpoint because I feel like it has less error, but we'd have to actually calculate that. So let's do the same problem. So problem 2 is exactly the same. No, it's not. We're going to make it the same though, because that one goes from -1 to 9. This one goes from 4 to -4 to 8. Let's just do what they have. I wanted it to be the same because I wanted you to see that the area better be close to 310, because that's how we'd be able to see. They better be the same or very similar for the area under the curve. All right. Well, let's do this one. The graph is still similar. We don't necessarily have to have the graph, but I'm just going to do the x part of the graph, which would mean I start at -4, and I have to go all the way to 8 into 4 subintervals. I don't know, 4, -3, -2, -1, 0. 1, 2, 3, 4. 1, 2, 3, 4. We'll do something like that, and we'll look at that in a second. So we're going to start with the change in x, and the change in x would be 8 minus the -4. How many numbers across do we just put tick marks on, right? Divided by how many subintervals we want, which is 4. So for this one, I get 3. 8, 9, 10, 11, 12. Yeah, 12 divided by 4 is 3. So it is saying 3 between each number. So we start at -4, 1, 2, 3. Basically here, right? I'm going to label that. That's -1. And then 1, 2, 3. That's going to be here, right? 1. This is 2, right? 1, 2 there. And then this one would be our next one, and this would be our last one. So 5 numbers. 4, this is 5. So 1, 2, 3, 4, 5 numbers break something into 4 pieces. Crazy, but that's how it works. So those numbers are your x sub zeros. Okay. So I like it this way. This is going to be x sub 0. Then this one will be x sub 1. This one will be x sub 2. This one will be x sub 3. And this will be x sub 4. Could you list them on the side like we did above? Of course. I kind of like looking at the visualization. I don't really care what's going on and how far up and it's going, or it could go down and be in a negative too. So if we dip down into the negative, you have negative area, which sounds crazy, but it totally makes sense for business. It's like, I am not making money. Oh, I'm making money. All right, so then from here, we're going to do our C sub 1. Okay, so our first C is using the first 2 numbers, and this time it says to take 2 times the first one plus the second one and divide it by 3. So basically, you're going to break it into 3, but you want to be a little more to the left. But that's what we're going to follow. So we're going to do 2 times the first number, which is -4. You don't have to have the parenthesis. It's a negative, so I like that. Plus the next number, which we said is -1, and divide that by 3. And we're going to get a pretty number of -3. Okay, so what does that -3 represent? It is representing that you are going to be right here, -3. That's where you're going to go up and hit your graph, right? So that's what you have to put into your function, because you need to get that side length of your rectangle. Okay. So our next C value will go 2 times. The next number would be the -1, and then you add it to the 2. Okay. So -1 and the 2 x numbers, right? And then we have to divide that by 3, which is going to give us 0. And the next one would then now be using that 2. So that 2 times the 2 plus the next one is 5. and divide that by 3, and that's going to give us 3. C sub 4 is going to be 2 times the 5 plus the 8 divided by 3, which is going to give us 6. So we'll do these all in red. You can see the 0 here, the 3 here, and the 6 here. So could you follow the pattern? Well, it's a pretty easy pattern because you have 3 on the bottom and you're doing it a little bit more to the left because you're timesing by 2 and dividing by 3. Okay, then what do I do with those numbers? I put them into my function. So f of 3 is going to be, we still have that same function, 7, was it plus? Let me look real quick. Sorry, 7 plus x squared, yeah. So 7 plus 3 squared is 16, 9, 16. I keep squish it in there. And then the next one would be a -3. And so, oh, no, the next one is 0, sorry. 0. Oh, this should have been a -3. No, it is, yeah. Sorry, this should have been a -3. Same answer though, because it's -3 squared. Use a parenthesis in your calculator, it'll give you the wrong answer. Because when you're putting it in for an x squared, you want to use a parenthesis because you're saying that's going to end up being positive. Because remember, there's a difference between -3 squared and -3 squared. And when you start with x squared, you're in this world. Okay, so use the parenthesis. Silly things like that, I don't want you to miss a big problem because of it. Okay, so we put in the 0. I think I was looking at this 3 instead of this 3. This is what I should have done. Because that was just our change in x. So that's what, and I lined it up wrong too. That's all right. So f sub 0 is going to give me 7 plus 0 squared, which is just 7. And then f sub 3 is going to give me that same 16 because 3 squared and -3 squared are all the same. And the last one is 6, which gives me 43. So I have to do the C's to know what number to put into the function. And now we can do our big sum. So our sum is going to have a sum of 4 rectangles. Always use parentheses, it'll just help. The first rectangle is going to be 3 by 16. The next rectangle will be 3 by 7. The next rectangle is going to be 3 by 16. And the last one is 3 by 43. So put that in your calculator and you get 246. So that's actually fairly similar to the 310, but we didn't start at the same number because the other one went from -9 or -1 to 9. So it shifted a little differently on the part, but okay. So I'm only gonna do those two. I think there's another, no, they're all just totally different. Okay. I'm only going to do those 2 Riemann sums. There are more examples in the Pearson website. If you go to actual Pearson website and you look in the multimedia library, if you need more examples, or from the homework, the extra, there's some videos in there if you need a little more. So the next kind of idea that it goes to is the bottom part of your notes at the beginning that we didn't really talk about. I don't find the notes super helpful until you've tried some of it. So it's trying to discuss, like, here you're going to do these sums, right? I don't know that reading that is going to be as helpful as just seeing the example. But this part is our properties, our rules that go with it. So our rule is, if you're going from nothing to nothing on an integral, if I'm not going anywhere, the area under the curve is going to be nothing. Okay, 0. If you don't go anywhere, there's nothing. It says if you switch from A to B, and then you switch and go from B to A, it's the opposite sign answer. You can multiply by a number and just pull it out, right? That kind of follows all derivative-ish stuff too. Then here, it's saying you can do the integral in between So the integral of one area plus another area, it's the same idea of like doing the area of a house. You can have the area of the top and the bottom and add them. Same with this. If you're doing the area of a curve, you could break it up, area of this plus the area of this, which we do with rectangles, right? We're doing area, 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 add them all up. And this last one is like, well, if you broke it up and you go from A to B, and then you go from A to C, and then C to B, that's the same as going from A to B. If you start and end eventually at the same ones, your area should be the same. Okay. So if you break it up, that should be the same. That's going to lead us, as I get you dizzy, as I move it up, into these rules here. So this problem is basically saying, okay, from 0 to 6 of x, the function x, you have an area of 18. If you have a squared, it's 72. If you have, or a squared, x squared, it's 72. And that one's from 0 to 6 also, but this one's 6 to 9, and it's 171. So what is this problem saying here? Well, it says from 0 to 4 of 3x. I think this is the one that they had the typo on because we go 0 to 6. I'm like, yeah, they have a typo on this one. These note packets have a lot of typos. I used to post the key, but I don't anymore because there are so many typos that mess people up that I'm like, no, you have to watch my video to get the key. Okay, so switch those up. Sorry. 0 to 6 of 3x. Well, we need an x. Ignore the 3 because we can pull the 3 out front and we look at the x term. So we're going to pull the 3 out and just think of going from 0 to 6 of just the x dx. Dx is just part of our notation, right, for integrals. And then what we're going to do is we know that we have 18 is this area right here, see? So we're going to replace that with 18, and we end up with just 3 times 18. Okay? So 3 times 18 is going to give me 54. Okay, the next one's a little bit harder. It has an x and an x squared, all from 0 to 6. So I'm going to think of it as the first part, which is 2 times the area of the x part, which is 18, plus the 0 to 6 of the x is the, or x squared is the 72. So I replaced the x with the 18, and I replaced the x squared with the 72. And then you just calculate that out, 108. That one's a little weird, but that's how I would think of it, like kind of replacing this part and this part with the values of their area there. Okay. This one's 0 to 7. That should be 9. I was like, we can't do that. That one works. So, okay. 0 to 9 of 2x squared. Well, let's go up here. 0 to 9. Well, we have 0 to 6 of an x squared, and then we have 6 to 9. So we were told, like, it's like your areas are buttoned up next to each other. I can get those areas and just add them together. So I'm going to go back down, give you a headache with my scrolling. I want to think of it as the 2 times, well, the first 0 to 6 was 72. I have 71 on here. I'm like, that's not right. And 2, and then the other one is 71. Okay. So this one's the first one. We're going to add it to 2 times the 171. Because this part, here's the 2, that just follows from here. From 0 to 9, I guess I can write that out. 0 to 6, right, of 2x squared is going to be the 2 times 72. And we need to add that to the 6 to 9 of the 2x squared, same thing, which is going to be the 2 times the 171. I did not include the dx, but there you go. So that's where that one comes from. So put that in your calculator, and I get 436. Okay. For 6, if I go the other way, right? The original problem in your note packet says from 0 to 6 is 18. So if I go 6 to 0, I change the sign. So this is the same as a negative 0 to 6 of 7x dx. So we're basically just going to change the sign, but plus we have that weird 7 in there. So I'm going to keep the 7 and times it by that 18, but I need to make this negative. 7's from there. The 18 is from what you were originally given. And my note says that's negative 126. Okay. Last problem. From 7 to 7 of something ugly is nothing. I didn't go anywhere. Supposed to be easier ones, but I don't care what the function is. I'm done. Plus, I don't have enough information. No, I could have done that, I guess, if you would have had more. But so I know these last couple are a little bit tricky. It's just kind of trying to go over the ideas of what you are allowed to do, kind of, in those rules with integrals. The focus is definitely going to be on Riemann sums. Okay. All right. That's all I got for you.